Hello everyone, how are you all? I think you guys are doing well with the balancing, and balancing is the most important topic of this chapter. Okay, you have to concentrate on it, and every day you should work with few examples that you come across in a chapter. Okay, and the first 3 chapters of science will have lot of chemical equations. So all the equations you can note it down in your book and try their balancing, so that it will become a practice for you. Okay, so in my last video we have already covered the 4 types of chemical reaction, namely first one is combination reaction, second one is decomposition reaction. We again had 3 types of decomposition reaction, and later endothermic reaction as well as exothermic reaction. We studied their examples also. And now we are going for the very important reaction for the exam point of view, that is our displacement reaction. Okay, so before we go for the displacement reaction, you must know one small concept. Okay, that is nothing but our reactivity series. Okay, fine. And I gave you the periodic table for you, where I have mentioned so many elements also. Okay, and what did scientists do is, scientists have arranged those elements in the increasing order of their reactivity. Okay, among the elements present in a periodic table, few elements are more reactive and few elements are less reactive actually. Okay, and how do you know which element is more reactive and which element is less reactive? It is to be known by seeing a series called reactivity series. Okay, it's a very important topic. So what is the series? Reactivity series. So using reactivity series, what you can come to know? You can come to know which element is more reactive and which element is less reactive. Okay, and I have a small trick to remember the reactivity series. Okay, say see a sentence. You just make one sentence. Please stop calling me a careless zebra. Instead, learn how copper saves gold. Okay, so this is the sentence that you all have to remember. If you can remember this sentence, you can remember the elements of reactivity series in its order. Okay, actually this is how scientists have arranged the elements in a reactivity series. See, their decreasing order of reactivity. Decreasing order of reactivity. That means, say firstly they have placed potassium. That means potassium is a very highly reactive element. After potassium, highly reactive element is sodium. Okay, little less reactive is calcium, and magnesium's reactivity is much more lesser than calcium. Okay, later comes aluminium, after that carbon, after that zinc, iron, lead, hydrogen, copper, silver, gold. Okay, the elements which are placed at the bottom, at the end, they are all less reactive elements. Okay, elements which are placed on the top, they are all high reactive elements. Okay, so this is the decreasing order of the reactivity. Decreasing order means you all know how to arrange. So this is the decreasing order of reactivity of elements which are there in a periodic table. Okay, so if I ask you, is calcium more reactive or less reactive than sodium? Then what is your answer? See, where is calcium coming? Calcium is coming below sodium, no? Yes. So that means sodium is more reactive. The one which is coming above is always more reactive. Okay. See, calcium is more reactive than magnesium. Magnesium is more reactive than aluminium. Aluminium is more reactive than carbon. Carbon is more reactive than zinc. Zinc is more reactive than iron. Iron is more reactive than lead, like that. Okay. So decreasing order of their reactivity, the scientists have arranged, and that order of elements we are calling it as reactivity series. Okay, they have arranged only these elements. Okay, and few more elements were there, but these are the elements that you have to remember for your 10th standard. okay, to answer the questions relating to displacement reaction. Clear everyone? Fine. Got to know about reactivity series? Just try to remember this sentence. Please, here P means potassium. Stop. S in the sense sodium. Calling. Here Ca is there, no? Ca is nothing but calcium. Me. M is there, no? M stands for magnesium. A stands for aluminium. Careless. In careless, that C stands for carbon. Okay. In zebra, that Z stands for zinc. Instead, I stands for iron. Learn. L stands for lead. How? H stands for hydrogen. Copper. C stands for copper. Okay. Save. S stands for silver. Gold. Gold. Okay. So this is a small trick that I am giving for you all to remember the reactivity series easily. Okay. Otherwise, this order to remember without any trick will be a difficult and it will be confusing also. Okay. So that is the reason I gave you this trick. If you can remember this sentence, that is more than enough. And you must also know here P is standing for potassium, S is standing for sodium. Okay. Like that you should correlate and remember the sequence. Clear everyone? So this is one important aspect that you should remember before going for the displacement reaction. Fine. And now we will see what is that displacement reaction. See, I have given a definition here. Just try to read it. The reaction in which more reactive element displaces less reactive element from its solution. So what do you understand by this? Displacing. What is the meaning of displacing? Instead of me, if someone is coming and standing here, then you say Nalini ma'am's position is displaced by someone. Yes or no? Say instead of me, I will go. Someone will come and stand here. Then what is the sentence that you will say? Nalini ma'am's position is displaced by someone. Okay. Occupying someone's position is called displacing. Occupying. Okay. Going into someone's position is called displacement. So here what will happen? Some more reactive element will occupy the position of less reactive element. Okay, clear everyone? Some more reactive element, you know which element is more reactive than which element, you know now. Yes or no? It is by learning reactivity series you came to know which element is more reactive than which element. Okay, and now what is displacement reaction? More reactive element will displace in the sense occupying the position. Okay, what do you mean by displacing? Displacing in the sense occupying the position of other element. Occupying the position of other element. This is what the meaning of displacement. Okay. So now you read the definition. Reaction in which more reactive element displaces, that means it will occupy the position of less reactive element from its solution. Okay. So when you see the example, you will understand it much clearly. Now let us go for the example. See, we have iron. Okay. So this is our iron. Iron, when you put it in a copper sulfate solution. Iron, when you put it in a copper sulfate solution, you will get iron sulfate. You will get iron sulfate plus copper. Okay. So how did you get this product here? You see, iron has occupied the position of copper, no? Fe has occupied the position of, it has removed copper from its place and it has occupied copper's place. That is why you are getting FeSO4. See, instead of copper, you have iron in the product. So what did our iron do? Iron is more reactive element than copper. You see the position of iron, where it is coming. Where is iron coming? Iron is here. And where is copper coming? Below. That means iron is more reactive than copper, no? Yes or no? So the one which is coming above is more reactive than below elements. Okay, so iron's position is here in the reactivity series. Copper position is somewhere at the bottom. So what does it indicate? Which element is more reactive here? Definitely iron is more reactive here. Okay, so that is the reason iron is more reactive. Iron is more reactive. So this iron is removing copper. See, some powerful guy is there in front of you. Say for example, one weak fellow is there, some powerful fellow is there. Powerful fellow can drag the weak fellow and occupy his position. No? The same concept here. This guy is more powerful, more reactive. So what it is doing? It is removing copper from a solution. Okay, and it is occupying copper's position. So you are getting iron sulfate and copper has come out freely, and you will get copper separately. Okay, and we can see the experiment also on this reaction. So how do you know that displacement reaction is happening here? Usually, how do you know when some chemical reaction is happening? How do you say that this is the chemical reaction happening? You can always say it by observing 4 factors. Yes or no? Either color will change, or state will change, or temperature will be changed, or by evolution of gas also. Okay, here this chemical reaction can be identified by change in color. Okay, so usually copper sulfate is in blue color. Copper sulfate is in blue color. Okay, and in a copper sulfate solution, I will add iron nails. Okay, nails you will get to know. I have got the experiment also. See here. This is our copper sulfate solution. Okay, see blue color solution is there. No, this is our copper sulfate solution. Okay, and to the copper sulfate solution, what I am adding? Iron nail I am adding. See, iron nail is here. Iron nail is here. Okay, one more nail I will take. It's at the bottom, if you can observe. See, to this copper sulfate solution, I am adding iron nail. And I will keep it for 1 hour or 1 day. Okay, the reaction is, it is less reactive. So that's the reason I am keeping it for 1 day. When I kept it for 1 day, okay, the same solution. See, I took a blue color copper sulfate solution. I am adding iron nail. Okay, and I am keeping it for 1 day. What I have got is solution like this. The same blue color copper sulfate solution turned like this, and iron nail has become brown. Can you see brown color stuff that has created on a iron nail? Yes, this is how the reaction happens. Okay, that blue color solution, see, this blue color solution is there. No, this is what our copper sulfate. And to this copper sulfate, what I have added? Iron nails I have added. Okay, so how the reaction happened? This iron removed copper from its place. Why? Because this guy is more powerful than this. And how do you come to know that this iron is more powerful than this? By the reactivity series. Clear? Iron's position is somewhere up. Copper's position is somewhere bottom. Yes? Through this reactivity series, you can come to know which element is more reactive than which element. Okay? So now this guy is more powerful. It has removed copper. So now the product is no more a copper sulfate. As long as the compound is copper sulfate, blue color will be there. Now it is not copper sulfate. Iron is occupying copper's position. You are getting iron sulfate. This is the color of iron sulfate. Okay. Your copper sulfate solution has converted into iron sulfate solution. Okay. And the copper will come out now. Copper will come out, right? And that particular copper is what deposited on the iron nail. You would have placed iron nail in the blue color solution, and above that iron nail, on the iron nail, that brown color copper's color is brown color. Brown color copper will be deposited. Okay, so this is what the experiment I have already done. Yesterday I took a copper sulfate solution. I have added a iron nail, and see, in this was the copper sulfate solution. Yesterday this solution was like this. Okay, and I added iron nail. This was the iron nail I added to the copper sulfate solution, and today when I saw, you see, the solution has turned like this. Okay, and this is our iron sulfate solution product, and whatever copper nail I have dipped here now, on that this brown color thing has been deposited, and this is what your copper. Clear everybody? Fine. So this is what we will call it as displacement reaction. Okay, this is very important example. Based on this particular example, question can be asked. They'll ask the questions like, how copper sulfate blue color disappeared? What happened? Okay, and how do you get copper? What is deposited on a nail? Copper is deposited on a nail. Yes or no? Why did blue color copper sulfate solution disappear? Why did that blue color will disappear from copper sulfate solution? Because iron is displacing copper from its solution. It is no more a copper sulfate. When copper sulfate is not there, blue color will not be there. Okay, if it is a copper sulfate, blue color will be there, right? So copper sulfate has completely become a iron sulfate. That is why blue color disappear. And what is the color of iron sulfate? Color of iron sulfate is light brown color or light greenish color also you will get. Okay, since I kept it for one whole day, the solution has turned a brown color. If you would have kept it for only 1 hour, light green color you would have observed. Okay, turning copper sulfate into light green color only for 1 hour if you would have kept. I kept it for 1 day, no, so dark color I have got. Clear everybody? So this is what we call it as displacement reaction. Okay, fine. And now one more. This is example number 1. These examples are very important to remember. This is our example number 1. And coming to the example number 2. Okay, and you are going to tell me the products now. Try to analyze the product. I am taking zinc. Okay, and I am adding it to iron sulfate solution now. I am taking iron sulfate solution. In that I have added zinc metal. Just like copper sulfate solution I added iron nail. No? Like that zinc iron sulfate solution. Okay, to that zinc I have added. Can you tell me what are the products you will get here? Can this be more powerful than iron? Can zinc be more powerful than iron? If it is more powerful, if it is more reactive, it will remove this metal. Yes or no? It will remove this iron from its position. How do you know that zinc is more powerful than iron or not? By checking into the reactivity series. Okay, just check the position. Where is our zinc coming? Zinc is coming here. And where is our iron is coming? Iron's position is here. Definitely zinc is coming above the iron. So the one which is coming above, the one which is placed above is always more reactive than the one which is placed below, no? Yes? So definitely our zinc can remove iron from its solution. Okay? So if zinc is removing iron and zinc will occupy the position of iron, so what is the product you will get? You will get zinc sulfate plus what is coming out? Fe is coming out. Okay? So this is how you have to write the products for displacement reaction. Yeah? Fine. And one more example I will show here. Just you are going to tell me whether displacement reaction takes place or not. Okay? Fine. I will take silver and I will take copper sulfate. Can I get any product? Do I get a product like ℏ(ʔSO4 plus copper? Can Ag remove copper from its place and occupy its position? Can Ag remove copper from this solution and occupy copper's position to get AgSO4? Will the reaction happen? Just try it over. How do you decide whether displacement reaction happens or not? Just check whether Ag is more powerful than copper or not. If this guy is more powerful, then only it can remove copper from its position, no? And how do you decide whether this is more powerful than this or not? Check the reactivity series. See the positions where Ag is coming and copper is coming. Where is our Ag is coming? Yes, Ag means what? Silver. Silver's position is below, copper's position is above. That means silver is less reactive than copper. Silver is less reactive than copper. So can silver remove copper's position? Never, right? If this guy is more powerful, then only it can remove this. But this guy is less powerful than copper. Okay, so silver cannot do anything here. Silver cannot occupy the position of copper. So this reaction will never happen. Okay, you will never get the products. You have to say there is no reaction. There is no reaction. You will never get AgSO4. You will never get AgSO4. See, you will never get AgSO4. What is the reason? Because Ag is less reactive than copper. Since it is less reactive, Ag cannot displace or cannot remove copper from its position. Okay, so this is how questions can be asked. They will give you certain questions and they'll ask you which among them is displacement reaction or not, they will ask. So you should carefully check how displacement reaction can happen. Okay, so for this displacement reaction, compulsorily you should remember the reactivity series, because you should decide whether which element is more reactive than which element. Okay, if the guy is more reactive only, it can remove the other less reactive guy from its solution. Okay, clear everybody? So this is what we call displacement reaction, and it is one of the very important topics. Okay, fine. So with this, I will end up the video. In the next video, we will talk about the double displacement reaction. Thank you.